All right, so here's our week 11 review video. I am going to run through questions 1 and 2 probably quickly at the end of the video, but then talk about them again in class tomorrow at the very beginning. So I'm really just going to focus on the rest of this packet. So let's go ahead and dive into question 3. So we're graphing, and remember the first part we always want to do is to graph the domain, and piecewise are set up into 2 different parts. There's an equation and a domain. So this first domain is x is less than 0, so I'm going to put an open circle at 0 and go to the left. And then it looks like our second one is going to be a closed circle at 0 and to the right for greater than or equal to 0. So, and then we're going to go ahead and graph our equations. Remember, we do that first in just regular pencil. So this equation says to start at 1 and do a slope of up 1 and to the right 1, up 1 to the right 1, and then down 1 and to the left 1. Right, I am just graphing this as the equation y equals x plus 1. So if it helps you to write y equals, feel free to do that. And then I need to match that with that domain. So I'm matching it with the domain here at the bottom, and I see that this one starts at 0 with an open circle and runs to the left. So I'm going to kind of trace that up and make an open circle and copy this one to the left. All right, now I'm going to move on to graph that second equation. So back to my regular pencil again. I'm going to start at -4, and then the slope is 2x, so that's up 2 over 1, up 2 over 1. Okay, and then this one is the blue domain, so I'm going to match that with what I have below. And this blue domain down here at the bottom tells me I need to start with a closed circle and go to the right. So I'm going to start with a closed circle here on 0 and go to the right. Some things to remember, you really need to make sure that down here at the bottom when you're doing domain in the beginning that you're not just sketching the domain, but you're really lining it up exactly with the numbers that it belongs to so that you can make sure your blue section matches, your red section matches, whatever colors you're going to use. You want to make sure that they're matching up correctly. All right, so let's take a look at question 4. And if you've already done question 4, I am just going to give you a warning. I know that part of this goes off the graph, so I am going to have to make that adjustment as well. All right, so again, start with my domains. So the first one is x is less than or equal to -2 here. So I'm going to find -2, make a closed circle, and go less than. The middle one is saying between -2 and 4, and that means I need to have an open circle on -2 and a closed circle on 4 because of those inequality signs, and then shaded in between. And then my last section is going to be x is greater than 4, so it's going to be an open circle on 4 and greater than. And now I need to go back and graph my equations. So again, if it helps you to write y equals, you can. So the first one is just y equals 5. So if I graph that with just my regular pencil, I know that looks like a line straight across just through 5. Except this only applies for the red domain. So I only want to copy that in that red section. So if I'm following my domain at the bottom, that means I need a closed circle here at the x value of -2 and then to the right. And I'm going to go back and erase that extra line that I don't need. Okay, my second equation for blue is y equals 3x. That's like y equals 3x plus 0, so I start at 0 and I go up 3 and to the right 1, up 3 to the right 1, down 3 to the left 1. And now I'm going to look at my domain down here at the bottom, and my domain tells me that at this -2 value here, I need an open circle. So I actually need to fix that and make that last one an open circle. And then it says this section ends if I can trace all the way over to 4. So if I look at 4, so this is where this one goes off the graph. Technically, I need to keep going up, up 3 and over 1, up 3 and over 1. That's about the best I got. And all we are doing here is denoting that this last one is a closed circle. We're going to connect all the way through. I'm pretty sure I've double-checked your test tomorrow to make sure things don't go off the graph, but I'll triple-check that tonight. Okay, so now we're to our last equation, which is y equals negative x. So that just, again, that's going to start at 0 and go down 1 to the left 1, down 1 to the left 1. I don't know if you can even see me making these points. There we go, down 1 to the left 1. And I could go up 1 and to the right 1, but I know that this is, I'm trying to get to the green section, so that's why I'm just going this one direction. So if I try to match my domain here at the bottom again, I know that I'm going to need to have an open circle and be going to the right. So I'm going to match that up and put an open circle right here, and then to the right, and hopefully you're drawing a little bit better than I do. All right, so there's question number 4. 5 and 6, very similar. We're just going backwards to actually write these. So on question 5 here, the same way that we start with domain when we graph, we want to start with domain when we write. So I'm going to copy the domain down here at the very bottom underneath the graph real quick. Open to open. And a few of you got to this question and you were like, this graph doesn't connect. I've got this open space in the middle. That's okay. It's okay to have that open space. You can't make something there if there isn't anything there. So let's go ahead and write our domains first. So that red section I see is starting at -5 and then going to the left. So that's going to be x is less than or equal to, because it's closed, -5. The blue domain is between -5 and 0, and those are both open. So that's going to be -5 less than x less than 0. Remember, these need to stay, when in doubt, make them less than symbols. I think most of you are getting really good at that now. And then the last section, we're going to be starting at 4 and moving to the right. So that's going to be x is greater than 4. And I just did greater than because that's an open circle also. All right, and now we just need to go back and write our equations. And the huge star we wrote in our notes is that equations, to write them, we have to start back at the y-axis. So we have to keep whatever slope is going. So I know this line, this first section right here, if I kept that going back until I hit the y-axis, I would come up with this line, which is just a horizontal line at -2. I know that's just the, like, y equals -2. So my equation is just -2 there. Okay, if I trace my second equation, so I'm going to be working on the blue one now, I'm trying to trace this back, and what am I saying? I don't even have to trace that back. It's already at the y-axis. That's hitting at +2, and if I count the slope from anywhere on this line, it's +1, up 1 over 1, up 1 to the right 1, up 1 to the right 1. So that means my equation is just going to be x, or you could say 1x if you wanted to, plus 2, because I'm starting at +2 on the y-axis. Now this green line I do have to actually trace back. I notice right now the slope is -1 to the right 1. So I'm going to kind of count that slope backwards until I can get all the way back to the y-axis. And it looks like I'm going to get back to the y-axis at +3, so this is going to be -x, because that's -1 over 1. Plus 3. If it's bothering you to write the equations just as parts like that, you can write y equals -1x plus 3 every time. Like, that does not bother me. However you need to set it up to make sense. The biggest thing, though, tomorrow is I need to know which equation is going with which domain. So you do not have to color code, but you can't have all these pieces just floating around randomly on your test. I need them to be next to each other or in a box together or something. So make sure that you're grouping those together. All right, question 6. Again, start with the domains. So I'm just going to copy my domains down here at the bottom. Open to the right. And I guess I could have overlapped those instead of making them separate. So this red line, I'm going to need to count back to the y-axis. I notice this currently has a slope of up 2 to the right 1, so I'm going to keep that going. Up 2 to the right 1. It looks like that's going to cross at 3. So the first one is, I guess I did equations and domains at the same time. Sorry about that. All right, so this first one is going to be 2x plus 3. And the domain there, I'm starting at -3 and going to the right, so that's x is less than or equal to -3. Okay, this second one, I already know where it's crossing the y-axis. That's right here at -1. And it turns out the slope is -1 also, because I'm going down 1 to the right 1. So this is negative x minus 1. And the domain down here at the bottom, looks like I'm starting at -3 with an open circle and moving to the right. So that's going to be x is greater than -3. And then if you want to be super fancy, you can put your little bracket and y equals there. All right, so there's your piecewise function. I know I did that out of order, but hopefully if you've already done that, you're checking that you got the right answer. Okay, this next section, we're all talking about graphing these absolute value equations, which you all know need to end up in the V shape. And really, we just need to start by naming the vertex every time. And to graph, you all know we're looking for just two things, really, the vertex and the slope. So let's go ahead and look at question 7. A few people get confused, or they try to confuse themselves because there's nothing in here with the x, but think about what I just said. There's nothing in there with the x. So the vertex itself here is going to be 0, -3. So that's 0, -3 is my vertex point. And then there's no slope written out here in the front, which means the slope is just 1. So that's up 1 and to the right 1. And then I'm matching up 1 and to the left 1 so that I end up with this V-shaped graph. So question 8. Similarly, we're going to look at the vertex first. Now on this one, there actually is a value on the inside, and you all know on the inside you're supposed to think opposite. So since the inside is opposite, that's going to be +2, and the outside is the same, so that's +1. Remember, that's these two values. The number in the very front is going to be my slope, and so here it looks like I've got a slope of -3. So if I plot that, I'm going to go to +2, +1 as my vertex, and then count a slope of -3, kind of like you normally would, down 3 and to the right 1, except I want a V shape, so I need to match that the other direction by going down 3 and to the left 1. So here is that graph. All right, question 9. Start with the vertex again. On the inside, it's the opposite, so that's +3. There is nothing on the outside out here, so that's just going to be 0. So my vertex point is going to be at 3, 0. And then my slope is going to be 2 out here in the front, so that's going to be up 2 and to the right 1, up 2 and to the left 1. If I graph that, get a V that looks something like that. All right, last question 10. Again, start with the vertex every time. So inside is opposite, and I notice that inside there's nothing being added, so that's just 0. Outside is the same, so that's +1. And my slope here, if I'm looking for the value in the very front, is there's just a negative sign. So similarly to if you just have -x, this is like -1. So I'm going to start at 0, 1. And count a slope of down 1 to the right 1 and down 1 to the left 1. And that's my graph. Okay, let's move on to page 3. So questions 11 through 14 are really taking that same concept and just working backwards. So to do that, again, we need to know the slope and the vertex. So I've got a vertex here of 2, 1. So my vertex is at 2, 1, and I have a slope of 1. So that means my equation is going to look like y equals a slope of 1. I don't even really have to write down, so I'm just going to start my absolute value bars. Inside is opposite, so that's going to be x minus 2, and outside is the same, so that's +1. All right, question 12. Name the vertex first. Looks like that's at 0, -4. And let's name the slope for ourselves so we can use that. That looks like up 1 over 2. So that's 1/2. So now if I go to write my equation, that's going to be y equals, this time I do have a slope, so I'm going to put that in the front, 1/2, absolute value. Inside's the opposite. And this is just 0, so really you don't have to put anything with the x. I mean, you could write x plus 0 or x minus 0 if you wanted to. I'm just going to put x by itself. And then outside's the same, so -4. So there's your final equation for question 12. Question 13. starting at 0, 0, so my vertex is at 0, 0. My slope, I'm just going to find where it crosses again in another good corner on either side. All right, so this is down 3 into the right 1. So that's a slope of -3. And you can even recognize that that should be a negative slope because the V is opening downward. So now when I go ahead and write this equation, it's going to give me y equals -3 for the slope, absolute value of x. Since there's a 0 in the x spot, I don't need to put anything with that. And since it says at the end, I could write +0 or just leave it empty at the end too. So that's the simplest way to write that equation. And then question 14, we need to, again, just doing the same thing over and over again, name the vertex, that's -2 and 5, and name the slope, this is -1, because I'm going down 1 to the right 1, down 1 to the left 1. So when I write my equation, that's y equals negative, and I'm just going to put the negative, but you can write -1, that's not going to count you off for me. Absolute value, inside's the opposite, so that's x plus 2. Outside's the same, so that's plus 5 at the end. All right, hopefully you're going to be good for the absolute value questions tomorrow. This last little section down here on this page is talking about domain and range. And you all were pretty good to know from the video, domain is always all real numbers. So domain, all real numbers. Domain, all real numbers. You should be able to do that at least on these questions without even having to think about it. And then our range our y values. So you can name the vertex if you want to, or you can just realize that the y value is this end value. So that's going to be y and a -3. And then to come up with this inequality symbol, I need to be thinking, does it open up so that the V looks like a normal V would, or does it open down? So upside down. If it opens up, then I'm going to use the greater than or equal to symbol. Down will be the less than or equal to symbol. And remember, all of this information is going to come from the slope. So I'm going to be looking up here at that slope in the front. And this slope is -1, which means I'm opening down. So that's this case. I need to have less than or equal to as my symbol. All right, 16. So similarly, I'm going to look at the last value for the range. That's range is y and a -4. And then I need to look at the slope to think about, is it greater than or less than? Well, this slope out here in the front, there isn't one out there. So you all know that just means up 1 over 1. That's positive, opening up. So that's going to be greater than or equal to -4. All right, last page. If you have paid any attention to this problem in real life, this problem is crazy. No one can walk 3 miles in a single minute. That's an insane pace. But for the sake of this problem, I just changed the numbers so that it would be easier for you to graph instead of giving you crazy numbers. So let's go ahead and do the graph first. Some of you like to do the table first, and that's totally fine, but I'm just going to go ahead and do the graph first because these numbers are pretty easy to count by. So a student walks for 5 minutes at a rate of 3 miles per minute. So I'm starting at 0, 0. They're walking 3 miles per minute for 5 minutes. So I'm going to count 3 miles per minute until I get to 5 minutes have passed. So that's 3 miles per minute. So let's see, that's 3, 6, 9, 12, and 15. All right, so that's for the first 5 minutes. I'm going to go ahead and graph that as my first section. And then it says they take 3 minutes at their locker to arrange their things. So this middle section, for the next 3 minutes, they're just standing at their locker, which means they're not moving anywhere. So their distance isn't going to change. So we're just going to stay here for 3 minutes. So notice that that's going from minute 5 to minute 8 because that's 3 minutes passing. And then it says they continue, they're going to go to class. It's going to take them 4 minutes. So I did not do well on this problem either. It does run off the graph. They're going to walk for 4 minutes at a rate of 1 mile per minute. So they're starting at 15, so if I walk for another minute, that's going to get me to 16, and then 17, and then 18, and then 19. All right, so I know that goes off the graph, but this last point here is going to be at 19 and at 12 down here at the bottom. Okay, so those are my 3 sections for this graph. The other thing that I should have done in this graph is I should have labeled each axis, which a lot of you did a really great job of doing that today in class. So the bottom one is minutes, and then the y-axis is going to end up being the distance, the total distance that's traveled. All right, so they want us to write a piecewise function to model this. So same thing I've done before, I'm going to start with my domains. And if you need to copy domains down here underneath your graph, you are more than welcome to do that. So this first, the red domain is from 0 to 5. And this is a little different, right? On word problems, you are going to have to start at 0 instead of the first one just kind of going on forever, because it doesn't make sense for time to go backwards forever. The next domain starts at 5 and runs to 8, so that's 5 less than or equal to x less than or equal to 8. And then the last domain is going to start at 8 and run until 12 minutes, because that's how long she walked altogether. And now we're just going to write our equations. So remember, with equations, if you have to put this as your star on your test tomorrow, like a note for yourself, equations always start at the y-axis. So luckily, my red one already starts there. It starts at 0. So I'm just going to count the slope. It looks like I have gone up 3 over 1. Or you could get that from the problem because it says 3 miles per minute. So that's going to be 3x. For my blue equation, I am noticing that this is a horizontal line, so if I trace that all the way back, it looks like that would have been hitting the y-axis at 15, and so that's just 15 because it's a completely horizontal line. And then our last section, this green section, now this one I am going to have to trace back. Remember, I went up 1 to the right 1, so I'm going to continue that, making sure that I remember that I've counted by ones, or sorry, that the y-axis is actually counting by 2. So down 1 to the left 1, down 1 to the left 1, down to the left. I'm just going to keep this pattern going until I hit the y-axis. Make sure that's a straight line, and it is. It looks like I'm hitting the y-axis at 7, and I'm counting 1 mile per minute, or 1 over 1, so that's x, or 1x if you want to write that, plus 7, because that's where we're starting on the y-axis. So there's my piecewise function for this situation. You can write y equals out here in the front if you want to. And then the last question says, what is the domain and range for the entire problem as a whole? So domain, like look down here at your domain. If you look at that as one whole thing, that's running from 0 to 12. So my domain is 0 to 12. Even though I know most, like for the absolute value, we said domain was all real numbers. Remember, for word problems, that hardly ever happens. It's going to make more sense for us to look at it in specific context. And then for the range, so domain are your x values, and think about on this problem, we found that by taking these graphs and like squishing them down, scrunching them down to the x-axis, realizing that it runs from 0 to 12. So think about the y-axis. In distance, we're running from 0 all the way to 19. Okay, or you can think about kind of squishing this over to the y-axis. Either way, our range is going from 0 to 19, so the range is going to be 0 less than or equal to y less than or equal to 19. Okay, so those are your domain and range there. That's all you have to watch for right now, even though this is completely optional. But I am going to take a minute to talk about those first 2 questions in your video, and then you can watch those first 2 questions again in class tomorrow just to get the most sense. Okay, so on these questions, remember that anytime you see this like f of -1, that just means to plug in -1. Well, the problem is here that we don't actually know where to plug that in because I've been given 3 different equations. But remember, the domain tells us when I'm allowed to use each equation. So if we think about that, I'm going to go ahead and draw myself just a little number line here for a domain. So x is less than or equal to -2. So if I draw my number line here, -2 and 4, less than or equal to, that's going to be closed and to the right. And the equation that applies for that section is 5, or y equals 5. On the middle section, it looks like it's open at -2 and to the right, and then closed at 4. And the equation that applies there is just 3x. And then the last section is going to be open on 4 and to the right. And the equation for that one is -x. So if we kind of color code it like that, you all know how to do domains. Instead of graphing the equations, I'm just going to list them above, because all I need to use the equations for is to plug in. So this is where this possibly gets a little tricky, I'm not sure. You have to think for yourself, -1, which color section is that in? If I'm thinking domains. So where is -1? Well, -1 is going to end up being in this blue section because it is between -2 and 4. So I'm going to take a second to just kind of color code that. This is in the blue section. -2 is, well, it's weird. That's like a on the edge. It's open for the blue, but it's closed for the red. So to me, -2, and in truth, -2 belongs to the red section. So this is -2. Okay, 4 is another tricky one. It's on the edge here. It's closed for blue and open for green, so it belongs to blue. It belongs to wherever it's closed. All right, let's zoom out so we can get these last few. Oh, it's just 6, okay. So the f of 6 one, 6 is going to end up in this green section over here because 6 is bigger than 4. So now that you know what sections they belong to, we're just going to plug into the equations that you have written above. So what I mean by that is f of -1 equals 3 times -1. That's -3. So my value is -3. I'll keep doing the blue section since I already started there. F of 4 is going to be 3 times 4, which is 12. So the value is 12. The last one, f of 6, that tells me to use that last equation, which is -x. So that's -6, which is just -6. The red one, I'm going to plug in f of -2. And the thing is, I've been plugging into where the x is, and on this one there is no x. It's just 5, so the answer is just 5. All right, hopefully that made some sense to you. I'm going to try question 2 real quick. I'm just going to do that one again, see if that helps solidify what we did in question 1. So if we look here at question 2, I'm going to start by making the domain for myself with the equations. So I'll do that over here. It looks like the only important point here is at 0, so that's the only turning point. So at 0 on the first one, I'm going to have open and to the left, and that equation is x plus 1. And then on the next domain, that's closed and to the right, and that one is x squared. So now we got to color code our different numbers to know where they belong. So if f is 0, that's this turning point, think about which one is closed, which one includes 0. That should be the blue one, so I'm going to color it blue. -2, let's see, that's over here in the red section for sure. And +4, that's going to be in the blue section because +4 is greater than 0. That's on the other side of the number line. So now we're just going to plug in f of 0 equals 0 squared. That just means 0 times 0, which is 0. F of 4 equals 4 squared, and 4 times 4 is 16, so 16. And then this middle one belongs to the red section, so that's f of negative 2 is negative 2 plus 1, which is negative 1, so negative 1. All right, hopefully you made some sense of that. We'll touch on that just a little bit more tomorrow. You might have one question on this, or it might even end up being an extra credit question for you, but do your best to make sense of this for your test tomorrow.